Okay, for those of you who were not here on Friday, you're going to be a little bit confused with what we're doing, and I guess you just got to hang on and hope for the best. Um, for those of you who were here on Friday, hope you're able to get your assignment done in class, and now you're able to do these problems with no issue at all. And what we want to do is we want to focus on, really this part of our notes. On Friday, we really covered this green section right here, where we translate between sine and cosine, tangent, cotangent, secant, cosecant, so on and so forth. Today, what we want to do is we want to focus on these next three, so equations 5, 6, and 7. Again, this sheet was not given to me. I put it together to help students. I think that it's a nice kind of graphic organizer of the different formulas and the forms that they could take. Now, if you notice on the very last page, you have this sheet of notes. This is the sheet of notes that you get for your test, okay? For your test on, in 2.5 weeks or 3 weeks or whenever it is. Now, it says sine squared plus cosine squared is 1. But from that, we could generate other formulas. For example, if I subtract sine squared from both sides, I would get cosine squared of x is equal to 1 minus sine squared. Right? If I just subtract a cosine squared from both sides, or sine squared from both sides. Well, as you notice, I write that formula right here. So cosine squared is also equal to 1 minus sine squared. If you subtract a sine squared from both sides, or a cosine squared, you get sine squared is equal to 1 minus cosine squared. It's right there, right? Notice that these are also difference of two squares. So how does x squared minus 9 factor? X minus 3 times x plus 3. So look at what we have here. 1 minus sine squared factors to 1 minus sine times 1 plus sine. Okay, so they also factor accordingly. I've done that for sine squared plus cosine squared is 1. The other one is 1 plus tangent squared is secant squared. The other one is 1 plus cotangent squared is cosecant squared. And you notice that there's some nice relationships written here. And if you just think about it, that if you pair 1 and a squared together, it often works out to be something else, is kind of the idea. So we're going to use really these ideas today. I would say on a Friday, we really covered level 1 type of problems. Today, we're going to start with level 2, and then we'll get to level 3 and 4 type problems, okay? And you'll be really happy throughout the whole process. So 1 minus cosine squared. Using equation number 5, what does that simplify to? So all of a sudden, this is sine squared of theta times cosecant. Well, that worked out pretty nice, didn't it? Did we learn how to simplify that on Friday? Yeah. This is sine squared of theta over 1 times, how do you rewrite cosecant? 1 over sine. So for those who weren't here on Friday, this is what we did Friday. Is we said cosecant can be written as 1 over sine. They're reciprocals. So now as you multiply them, one of the signs will cancel, giving you just sine of theta. Done. Letter N, secant squared minus 1. Is that something special? Tangent squared, yeah. So this simplifies to cosine squared times secant squared minus 1 is tangent squared of theta. Again, on Friday, we learned how to simplify that. We have cosine squared over 1 times sine squared over cosine squared. Well, no. Secant, if it was cosine squared of theta times secant squared, these are reciprocals, right? And I would get just 1. But because it's secant squared minus 1, I could substitute in tangent squared due to this formula right here. If you look at equation 6, if we were to subtract a 1 from both sides, we get this formula. Tangent squared is secant squared minus 1. So because I see the secant squared minus 1, I could substitute in tangent squared. Now I rewrite tangent squared as sine squared over cosine squared. Cosine squareds cancel. Sine squared. Letter O, secant squared minus 1. We just did it. Tangent squared. Good thing we were here on Friday. Now we know how to do that one. How do you rewrite tangent squared? Sine squares cancel. What do you get? 1 over cosine squared. B. Rodden says 1 over cosine is secant. He's correct. Secant squared of theta. It's okay. I'm boring. Get it. All right, letter P. Let's talk about the mistakes that people make. Anybody see what people do right away? It's totally illegal. Yeah, so somebody right away first started like, well, tangent squared minus tangent squared is 0 times sine squared is 0. The answer is 0. Done. No. Okay. Order of operations. If I said 4 minus 4 times 5, that's not 0, is it? You got to take the 4 times 5 first. So, well, sometimes it's helpful if we factor something out. So if I had x squared minus x squared times y squared, what's the common factor for both those terms? Take out the x squared and you get 1 minus y squared, right? So what's the common factor you could take out of this? Tangent squared. 1 minus sine squared. If only we knew what 1 minus sine squared was. What is it? It's cosine squared. Oh, thank goodness. I was worried there for a minute. Oh, if only we could simplify tangent squared times cosine squared. Sine squared over cosine squared times cosine squared over 1. What happens? And I get let's skip Q. Let's do R, because we're pirates today. What can you factor out? And when I factor out cosine squared, I get 1 plus. Sweet. 1 plus tangent squared. That looks confusing. Yeah, it's kind of staring you right in the face, isn't it? It's right here. There's problem number 6, or equation number 6. 1 plus tangent squared is secant squared. There's the formula. What's the relationship between cosine and secant? They're reciprocals. If you multiply reciprocals, you get 1. We're in high school. We make boxes, not circles. What? I guess if you just want to be different than everybody, then go ahead. Whatever, Casey. All right, here we go. Yeah. Yeah, you can. I'll show you how someday. No, I can't. I'm human, so I have error. So we have tangent squared over secant of theta minus 1. Now, anybody tempted to substitute something in for secant minus 1? What? Yeah, it's not squared, is it? It's not squared, is it? That's a great idea, but it won't work either. So a lot of people in this situation, they want to put in tangent squared because they're like, well, secant minus 1, that looks like, the tangent squared piece, but it's secant squared minus 1. So some people do this. They're like, well, then that must be tangent. The secant minus 1 must be tangent then. We'll just unsquare everything. Well, that's totally illegal. Okay, now you're just making up stuff. And that happens quite a bit on the test. It's a hard test for me to grade. Unfactor. Yeah, well, there's an idea. Let's unfactor tangent squared. So didn't we just state from up above that tangent squared was the same thing as secant squared minus 1? So now I have this piece. I have secant squared minus 1 over secant minus 1. Well, we talked at the beginning of class how secant squared minus 1 is the difference of two squares, right? So how's that factored? Trig. She thinks trig is hilarious. All right. So what happens? Oh, do I get my finger cut off? No, because, you know, it's an entire term. It's in parentheses, you know. It's factored. So we get secant of theta plus 1. We're done. Very similar to problem B. What do you think we'll substitute in here? Come on, instead of sine squared, what do you want? Instead of sine squared, I want 1 minus cosine squared. Okay, so Lauren's raising a great question, although it's really not being raised. I'm reading her mind, and in her mind, she's saying, how come? Why on earth would you even do that? If you just try to, this is what you have to get good at. If you can't, that's fine. That's the measure of, you know, where you are as a math student. But you want to look ahead and you want to say, well, what is the advantage of doing that? If you could recognize that this factors, will something cancel? So it looks like we made a good choice to substitute something in. But unfortunately, I can't tell you the steps to follow each and every time. You got to just try different methods and see what happens. It's kind of like solving a puzzle. So we get cosine of theta plus 1 divided by, this will factor to 1 minus cosine of theta times 1 plus cosine of theta. Is cosine of theta plus 1 the same as 1 plus cosine of theta? They are. Addition is commutative, so you can switch it around. And it's fine. I get 1 over 1 minus cosine of theta. What's different about letter C? What's different about letter C? It's different. Thank you. There's no squared. Can I make a squared? Yeah, just distribute, right?
No, you can't.
Secant times secant is secant squared minus what's secant times cosine? It's 1. They're reciprocals. You multiply them and get 1. If only we knew what secant squared minus 1 was. Hey, it's tangent squared. Look at that. Life is good. Just a fair warning, folks. If you haven't started the assignment yet for Friday, you know, you obviously get part today, but you're going to have an assignment on this again tomorrow that kind of encompasses all the parts we've covered. So you're gonna have the entire hour in class to work on it. But so you're going to want to make sure you get moving on this stuff. Sine times sine, sine squared. And then sine times the quantity cosecant cosine squared. What's the relationship between sine and cosecant? So you get 1 times cosine squared, which is shoot. If only we knew what sine squared plus cosine squared was. Jake and Lolly said it. It's 1. You're wondering how I know it's 1, right? I will show you how we know it's 1. If it was a snake, it'd bite you. Sine squared plus cosine squared is 1. It is the most important trigonometric identity that you need to know. And is this the first time we've seen it? We used it all the time in chapter 5. YouTube, in case you're kind of struggling with the flow of class, my students, every time I ask them a question like, have they seen it before? They're like, no. And they're being obstinate. So, yeah, all right. But it's a funny Monday. That's where we're at. All right, so it's your turn to take over class. What do you want to do with E? You see the problem? It's already factored. Foil it. Okay, what's foil? 1 times 1? 1. 1 times positive cosine? Positive cosine. Negative cosine times 1? Negative cosine. Negative cosine times cosine? Negative cosine squared. Hey, what happens in the middle? Why do they cancel? What do we call that when it's a minus and a plus? Spanish. So does C. Rhymes with conjugate. They're conjugates, okay? So the middles go away, and you're left with 1 minus cosine squared of theta. Do we know what 1 minus cosine squared is? Sine squared. But what if you did? Let's try F. Are these conjugates? So the middles will cancel. I'll get tangent squared minus secant squared. What is that? It is not 1. It is negative 1. So if you remember the formula that's on your page, we have 1 plus tangent squared equals secant squared. Well, that doesn't look exactly like that, does it? But if I subtracted a secant squared and subtracted a 1, you would get tangent squared minus secant squared is equal to negative 1. So, looks like we made up a new formula. How about letter G? 4 secant squared of theta minus 4. Uh-oh. Wish I could get rid of that 4. Let's factor it out. What's secant squared minus 1? It would be great if, being it's Elena's birthday, if, like, this lesson was so meaningful that it was forever imprinted in your brain on your birthday. It's like every time you have a birthday, you're like, oh, trigonometric identities. Yeah, go tattoo time. All right, yeah. There you go. Sine squared plus cosine squared is 1 right on your forehead. Yeah. Or the underside of your lip. Have you ever seen a lip tattoo? Oh, that would hurt. Oh. Okay. All right. Letter H. Now we embark on level 4 type problems. We've seen level 1, level 2, level 3. What about level 4 type problems? Oh, no. Okay. Some people are done. What if we did know what to do? What's a strategy? What do you think is a good strategy? Okay. So, Jake is seeing that there's really no option here other than just trying to convert to sine and cosine and maybe see what happens. So if you just try to peek ahead, you could see that if you were to change tangent to sine over cosine, then the cosines would go away, wouldn't they? Plus, and then if I change that, I got cosine over sine times cosine. And some people will feel frustrated because they're like, well, nothing cancels there. Well, but will you get a squared? Well, getting squareds is always a good thing. Cosines go away. So I have sine of theta over 1 plus cosine squared over sine of theta. Now, on the test, some people try to cancel the signs at this point. That's where you cut off a finger. That's reducing parts, okay? That's totally illegal. But if you notice, I have sine in the denominator. What if I created common denominators? Then I'd have a squared on this side, right? Kind of jumped ahead there. Sine of theta, not sine squared, sine of theta. Well, now, what do I have on the left-hand side? Sine squared. What do I have on the right-hand side? Cosine squared. What do you have in the denominator? So it still looks kind of ugly. If only we knew what sine squared plus cosine squared was. It's 1. The numerator, sine squared plus cosine squared is 1, and 1 over sine is. Cosecant. Sine times sine. Sine squared. Cosine squared. The denominator between the two is sine. Sine squared plus cosine squared is 1. The next one works out almost identical. Sine squared times secant. I'm going to write it as sine squared theta over 1 times 1 over cosine plus cosine over 1. I've got a squared. I like that. Could I create another squared? Common denominators will create another squared. What is now in my numerator? Thankfully, yeah. Well, the denominator over here on the left-hand side is cosine, right? And the denominator here is now cosine. So I get 1 over cosine, which is secant. 3 more. I think you should try J on your own. Go. Okay, I rewrite it like this. And I get 1 minus sine squared. What is 1 minus sine squared? That's all there is to it. So your cosines cancel. Wadaliacha. Doodly doo. Doodly doo. All right, so let's try a couple level 4 type problems. Question? Why is what cosine? This? Why is 1 minus sine squared cosine squared? Because of number 5 on your sheet. Number 5 on your sheet says right here sine squared plus cosine squared is 1, which brings you to a new formula of sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Boom. 2 more problems. And I would say that this is the content limit of what I would ask you to do on the test is problems like K and L. So let's see if we can handle them. What do you want to try for K? Okay, let's try common denominator. So what do I end up with in the numerator? Well, I get this times 1, which is cosecant of x, plus 1, plus, and then here I get sine of x, plus 1, right? Yes, and 1 plus 1 is 2, and which is dos, which is Spanish for 2.
Spanish for 2.
But look at our denominator. Our denominator is cosecant of x plus 1 times sine of x plus 1. You just cross all out. So like if you had 9 plus 8 over 9 times 8, you could just go, all right, we're done. Or if you had like sine of x and you're dividing by n, you could just cross the n's off and you're left with 6. That's the kind of math we're going to do. That's what we want to do. Okay, all right. So, we really don't have an option there, but maybe if you want to do the bottom? Let's do the bottom, see what we get. What's cosecant times sine? Hold on, right at the top. Cosecant of x plus 1 plus sine of x plus 1. You can raise plus 2, that's fine as well. What's cosecant times sine? 1. What's cosecant times 1? What's 1 times sine? And what's 1 times 1? Is that the same? Is it? Close. It is the same. It's not close. It is the same. So we do get 1. Yep. If you would cross stuff off like that on the test, I would give you 0 points. So I don't have to do anything. How about letter L? Last one. What would you like to try? Okay, cotangent first. We got sine of x. Common denominators. Okay, let's try it. I can't cross off the sine of x, as people do that, and that's worth 0 points. All right, so what do we get in the numerator? Okay, so Carter's seen something important here, that when you distribute the cosine, you have to distribute it to both parts. So we get cosine of x plus cosine squared. And in the denominator, what's my denominator? I'm going to leave it factored. And this is the part where, unless you see something, you can't really move forward. So I can't make this just happen for you. Hopefully you have to see it. What do you see, Jake? sine squared plus cosine squared is 1. So now what you have in the numerator is 1 plus cosine of x divided by sine of x times 1 plus cosine of x. One over sine is not secant. Oh, all right. I said secant. Cosecant. So I understand these are not easy problems. You now understand that there's no guarantee that you're just going to get this stuff come test time. You're going to have to work hard at it. You might have to do something new, which is come in for help, which I know is not the popular thing to do these days. And just remember, this is the last week that I'm available at all after school. So what is your assignment?
Stop it.
So, no, just settle down. Your assignment. On Friday, I gave you a certain set of problems. If you combine Friday and Mondays together, that takes you 1 through 22 all. So if you already did Friday's assignment, then these are the extras that you need to do. At the end of the day, you just between Friday and Monday, you have to complete 1 through 22. Yes, I'm intending this to be one assignment. You just extend on to your next assignment this way. I would not try to do this on one sheet of paper. Those of you who like to fit everything on one line, use more than one line per problem. And you must show your work. As I said, you can't just write down your answers. If you get a bachelor's degree in mathematics, then go ahead and start just writing down, the answer once you see it.